Okay, we are going to be solving exponential equations today without the use of logarithms. So an exponential equation is an equation in which the variable expressions occur as exponents. So your exponents, your variables are going to be in the exponent. That's what that means in a glorified way. All right. The property of equality for exponential equations says this in algebra. If b is a positive number other than 1, then b to the x equals b to the y if and only if x is equal to y. And we're going to be using that today. An example, if we have 5 to the x power is equal to 5 to the 4th power, then the only way that that works is if x is equal to 4. And so... All right, so this is our first example. Now, what you want to do is you want to take all of your bases and write them with the same base. So I have 64 raised to the x power is equal to 16 raised to the x plus 1 power. I can write both 64 and 16 with a base of 4. So I do that. 64 is 4 to the 3rd power. 16 is 4 to the 2nd power, and then I use exponent rules, which we learned very early on in first semester. And this is a product power here, so 3 times x, I multiply those, is equal to 2x, 2 times x plus 1, which is 2x plus 2. So then I solve this. This looks just like an equation. This looks just like an equation that you would have seen in pre-algebra in the 8th grade. So then I just move the 2x over here, and I get x is equal to 2. So my solution is 2, and I would substitute that back into the problem for x to be sure that I got the same thing. So 64 squared, 4,096. 16 to the 2 plus 1 power would be 16 to the 3rd power, which is 4,096. Okay, now if you'll notice here, they have the same base, so I've just dropped the base and set the exponents equal to each other, and I have 3 minus 2x equals negative x, and I pull 2x over here to be with x. So 3 is equal to x, and then I check it out. So 5 to the 3 minus 2 times 3, I just plug 3 back in, is 5 to the negative 3 power, and that's what I have here, 5 to the negative 3 power. So therefore you see that it does work. Again, bear in mind that we are writing everything with the same base. Now, this one says 2x over 2x. Well, if you remember your exponent rules, when they're like that, you subtract exponents. So x minus x is 0. So 2 to the 0 power equals 3 to the 3x power. So therefore, again, drop your bases. 0 equals 3x, divide by 3 on both sides, and 0 is x. Now you do your check over here. 2 to the 0 over 2 to the 0 is 1 over 1, and 3 times 0 is 1. 2 to the 0 again, so 1 equals 1. Let's do the next one. All right, now these are written side by side. They have the same base. Again, we have 3, and if you remember your exponent rules, you're used to seeing it simple, like this. 3 squared times 3 to the 3rd, and you just add and write 3 to the 5th. So you're used to seeing it simple. But this is the same thing. We have this base here. We're just going to add these exponents. So negative 2x plus 1 plus negative 2x minus 3. The x's cancel out. No, they don't cancel out, sorry. Negative 2x and negative 2x is negative 4x. 1 and negative 3 are negative 2 equals negative x. And then I solve. I move the 4x over here. I end up with 3x equals negative 2. Then I divide by 3, and so I have the x is equal to negative 2/3. Thank you. But remember, you're writing them as the same base and then setting them equal to each other.